All right, let's talk it out here. So Mark highlighted a dilation, and then he highlighted the definition. Technically, it's a transformation that maintains shape, but not size, because it does what to the sides? Yeah, it multiplies. And we're going to call that a scale factor. And then he also highlighted that dilations involve a point. And that's going to be called the point of dilation. Okay? Diamond, what did you underline that was like above?
Rigid transformation.
Yeah, and what is a rigid transformation?
I said it was translation, rotation, reflection.
And why are those rigid transformations?
Because they all maintain the size and shape.
Perfect. They maintain size and shape. All right. Well, let's summarize. Let's see if we can do this. You can call it out as a class. You come up with one word.
Mirror.
Good. Reflection would be mirror or flip. Rotation.
Spin.
Spin or turn. Joel. Translation. Or move. Good.
I'll put a shift.
Yeah, that works too. Shift, I think, works. Who's a brave soul with a hand? Oh, Lizette. Thank you for volunteering. I know, it's the silent hand. What's a dilation? What words would you use for dilation? Yeah. Ooh, very nice. You could stretch or shrink. That was the high order one. I think a lot of people will say. And what's happening to the dimension?
Enlargement.
Or
I was going to say minimize.
It shrunk.
What's up with dilate?
larger, smaller, enlarge, reduce. But I like this idea of stretch and shrink. Stretch and shrink.
If I put dilate, whatever.
Well, that's redundant.
But it's in the word.
So the idea here is you're looking for a word to help you if you don't know what dilate means.
Good. What's a rigid transformation then? Miguel, what's a rigid transformation? I know.
Well, you want examples or you want an actual definition?
Either one.
Oh.
All right, well, listen up. Go ahead, Lizette.
When it maintains the same size and shape.
Yeah, maintains or preserves. And what is it?
Well,
What does it have to preserve? What does it have to keep the same?
original shape.
Size?
And shape.
Good. Size and shape.
No.
When we say size, you're talking about, you're talking about length or the sides. Nothing about the sides change. When we talk about shape, what are we talking about? But what controls size is the length of the sides. What controls shape? What is it?
Angles.
Angles. Okay, so a rigid transformation keeps sides and angles the same. Is a dilation a rigid transformation?
I said no.
Why not?
Because it does like maintain the shape, but it changes the size.
It multiplies dimensions.
Yeah.
Perfect. All of that is correct. Size is not preserved because it's getting multiplied. The dimensions are either going to get bigger or smaller. Only shape is preserved. We're going to try, okay, what math operation is a dilation? Someone else. Rosano, AD. Yeah, multiplication. No. And you're thank you for that, because you're preempting my next question. Dilations are just multiplication. You do not divide in a dilation. I know you're saying, well, that's how I was going to make it smaller, right? Well, how would you make something bigger? What would you multiply by?
Positive.
Okay.
Oh, you can multiply by a negative number.
We'll do this, I guess. I'm going to get out my keyboard just because I know it will be, that's fine. Yeah. Yeah, so that's the hypothesis, right? Okay. You got this segment, right? How long is it? 3. So if you dilate it by a scale factor of 2, what's going to happen?
When it gets smaller.
Well, if you dilate it by a scale factor of 2, how much bigger?
It doubles.
It doubles. It gets multiplied by. So it's going to go from 3 to
6.
It went from 3 boxes to 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So how would you make it smaller?
Multiply by a negative number.
All right, let's try that. Let's try.
Don't you multiply by decimal?
Well, let's try the original thing. -2. Did it get smaller?
No.
No, it's still getting bigger. What changed though? Yeah, the location. Negative makes it go the opposite way. So Matthew, how do you make it smaller?
Well, like you multiply by decimal. So
What kind of a decimal?
like I would say 0.5.
If we want to make it the opposite of double, you want to cut it
In half.
in half. You multiply by a fraction, a decimal, a half, 0.5 or a half. That will make it half the size. That's why dilations are only multiplication. Yeah. What do you think will happen?
It's gonna be
doing nothing. I think it's gonna stay the same. Yeah.
No. He's right. If you so let's undo everything. If we dilate that by a scale factor of what operation is dilation? If you have 1,000,000 times 0, what's it become?
0.
If you have a cajillion times 0.
0.
So what should happen to 3 times 0?
Nothing.
Where does it go?
It's 0.
It goes to the point of dilation. Wherever you're dilating from, that's where it's going to disappear to. If you want to keep it the same length, what should you dilate by?
1.
You should dilate by 1. If you want to keep this the same, dilate by 1. I'm going to dilate by -1 just to show you that I can change its location, but size will stay the same. It's still 3. Because multiplying by 1 keeps everything the same. Okay? I think that's pretty clear, right? But what about...
What if you multiply by the square root?
Don't look at that. Don't look at that.
Don't worry about that.
Okay. What about a point? If we were to dilate a point by a scale factor of 2,
Wouldn't it become a line segment?
well, no, I mean, it's a point,
Wait,
right?
can you
It's got to
repeat that
stay a
question?
point.
I know, but I thought you
Can you
meant
repeat the
if you want to
question?
make it less, so you could just.
Well, that,
Repeat the question. That's all.
if I dilate by 2, is it getting bigger or smaller? But how is a point get bigger?
It's not getting bigger, but it's like the number of the point.
I like that. What's happening is the location is going to change somehow by 2, and you're saying do what? Multiply what about the point?
I mean, if you want to make it less, don't you multiply by a negative number? Like, yeah, I don't know.
Can you ask the question?
That point is wrong with it.
What does it mean to dilate a point by a scale factor of 2?
Multiply it.
You multiply the numbers, the coordinates.
Yeah, you could think of this as coordinates, and it would work that way. So if we were like trying to persist on our own, that method would work. Watch what happens when you dilate that point. What do you want the scale factor to be? 2.
5.
You see how it went here? You're right. The coordinates. Gotcha. What's happening to -1 to get to -2? You listen?
No.
Michaela, what happened to 2 to get to 4? Double. What's happening to -1 to get to -2?
Wait, what's it?
Double. It got multiplied by our scale factor.
Those points actually,
What's that?
those points aren't actually.
Yes, they are. This point is the coordinate -1, +2.
How are you?
How far away is A from our point of dilation?
So,
To what?
yeah,
2 units to the left?
2 units up.
Oh, 2 units up, just that?
And 1 unit to the right.
Wait, are you trying to find the coordinates? Oh, 0, 2.
So it's like a rise of 2 and a run of 1?
Yeah.
1.
So if you want to dilate, if you dilate once, nothing changes. You rise 2, run 1. If you want to dilate by 2,
You do it
you
again.
do it again. Rise 2 and run 1.
Yeah, so,
Yeah.
What a coincidence.
So if we want to do it 3 times
You go up 1 more time.
and over 1. So if we do this a dilation of 3, A is going to land over here. It's going to go up 2 over 1. That's a dilation of 1. Up 2 over 1. That's 2 times we've done it. Up 2 over 1. That's 3 times we've done it. So it should land right there. Language.
Sorry.
Boom.
Not loud.
Because what's getting what's getting changed what's getting tripled is the distance. Yeah. From each point to the point of dilation. Well, this is like that distance from the point of dilation to the point where dilating. That's a dilation of 1. If you do it again, that's a dilation of 2. If you do it a third time, it's a dilation of 3.
Then a 4 times the dilation of 4.
Yeah, perfect. But that's the method. So as I change that point of dilation, it won't let me. Well, that's fine. So if we dilate this segment by a scale factor of 2, I understand it's going to go from a length of 3 to a length of 6. But where is A going to go? Well, how far away is A? How far away is A from the point of dilation?
1. So it rises 3, runs 1. Right?
So it's positive 1.
So this is how you'll think about it. What's the rise and run from the point of dilation to A?
1.
You rise 1, you run 1. That's a dilation of 1. How many times do we want to do this?
4. It doesn't matter.
Let's do 2. So we did it once. We got to do it.
Okay.
So rise 1, run 1. A prime should land right there. You're going to do the next one. How far away is B?
1, 2. Well, 2 from B where it says there, right? So you go up 2 from where B is. So these 2 from.
So starting at O, give me directions how to get to B.
Down 2 over 1.
Down 2.
Over 1 to the left.
So then if we want to do a dilation of 2,
You go up.
You go down 2 more, and you go 1 more to the right.
you're going to do it again. Down 2 more and over to the right 1.
So wouldn't you just basically be multiplying its coordinates and finding the point?
Yes, that only works when your center of dilation is the origin, and because we're in Common Core, they're going to change that on you. So I'm teaching you the method. The method is just count the slope and then repeat that however many times. So if we want to do this a third time, if we want to do a scale factor of 3, we would do it 1 time, 2 times, and then where would the third one go?
Of which one?
From here.
Where he is.
Tell me how to get to the third point.
4.
But what would I do from here?
Go down
Go
2
down to the right.
over 1.
Perfect. How would I get to the third point from here?
Up to 1 to the right.
What is it?
No, up 1, up over 1.
Yeah, because they're going to have different slopes. This one was up 1 over 1. So that's 1 time.
Wait, are you
Up
trying
1
to draw a
over
shape?
1. That's 2 times. Up 1 over 1. That's 3 times. So when we connect these,
Here.
Oh. I'm smart. I knew you was going to make triangle.
well, that's why we do the next couple lessons are going to lead into these kinds of shapes. So a dilation of 1, nothing changes. A dilation of 2 is the green, because we went 1, 2 times. We went down 2 over 1, 2 times. To go 3 times is the blue. You'd repeat those slopes once, twice, 3 times. You'd repeat these slopes once, twice, 3 times. That's how you'll do these dilations. And you'll see the results are 3, 6, and 9. You are going to try the triangles. Number 3 and number 4. 5 minutes to try them out. 5 minutes. We just did those.
Wait, what do you want us to do?
I want you to clarify. I want you to do, 3 and 4.
Oh, yeah, but like,
Yeah, but like what?
Yeah, I was before.
Oh, wow.
I was part of the.
Making it bigger by the
But listen, can you come up with the first one?
So when we do these dilations, you need to know the point of dilation, which is 0, 0, the origin, and then how much is our scale factor? How many times are we doing this? So then, how far away is A from the center of dilation?
2.
Yeah, so we're going to do that once, and then how many more times? Yeah, because the total of 3. That was 1, 2, 3 times. So what would this point be called?
Is that around -6? Wait, what?
A prime.
Oh, okay.
I don't care about the coordinates. You can figure that out. Can you do B for me?
Wait, why would that be A prime if you did it twice? So wouldn't this be, that's the original, and then this would be A prime, and then wouldn't that be A prime?
Well, the transformation is to do it 3 times.
Oh, okay.
That's why. Good. The transformation wasn't do it twice and then a 3rd time. Where would B prime go? Can you do this one here? Try.
If it goes like that, right? If it goes like that.
That's 1,
then like
2. Well, that's a dilation of 2.
Yeah, but that's what you did over here.
Ah, I did once, twice,
Oh, okay.
3 times. It's just in here, it's,
Right there.
so you put it in. And then what would it be called? Now, C is going to be the test. You talk it out on it.
Talk it out. Wow. Okay, Miss, I'm done. Yeah.
Very good.
Right?
Proud of it. And then you connect them. And then I'm going to ask you, what do you notice about corresponding sides? You'll answer that when you connect. Anybody else want? No. Can you do this one on here and talk it out?
I don't want to do it.
Can they do it? I don't know how to do it. I just divided. Wait. So 1, 2, 3, 4. 1, 2.
I know you're working on it still. Matthew's gonna pass out our.
2, 3, 4. Wait. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And so this would go 1, 2, 3 over here, and then 1, 2 because
We want to go.
and then this crap 1, 2, and 2, and then this goes down 1, 1, 1. Oh, you see what you did? Oh, yeah.
See what you did?
Alright, now I got this.
That was me.
1, 2, 1. But it's like.
For some reason, I feel like I did this one. 1, 2, 1, 2. I did not do it like that. Wait. Let's go right here.
I was gonna jump over the fence.
Can you do this one?
No, you could do it.
I want to do this one. I feel like I'm doing this wrong.
You did it.
I think I did.
Yeah, you did it.
Nah, I feel like- Yeah, this one goes right here.
Yeah.
Right? Yeah, okay. I was trying to decide which way it goes, and then I don't know how to draw. And then I'm totally good drawing.
Yep. Artist of the year.
Dilation 1. We want to go half.
No, don't put it down. I'll put it this.
You don't want to go 4. You want to go.
Why are you guys giving it to me? Now do your practice, nerds. Clark Kent. I'm Batman. I'm Bruce Wayne. Miguel Morris. I don't watch The Flash. Yeah. Now we go. I watch Daredevil. You watch Daredevil? The show. I'm Daredevil, bro. White and I'm blind. Just give him glasses and he'll be able to see. Why would you give him water?
What's this, Willie? Ball
No,
This is actually.
Wilson Fisk. No, Miguel. We're talking about superheroes. Jose goes to your Wonder Woman.
Okay. You did it. Very good.
Drop.
So now you're going to the next practice phase. Yes.
I did it.
Okay, so I'm gonna once you start locking this up, if you make mistakes, and you won't be able to see.
Miss, you can never force me to use pencil.
So, what's your question?
No.
And then when you.
I got hungry.
Can you try that out? On number 2. You're not going to double.
So, if you want to know that it's confident that I bring there, it's slow.
They'll be parallel. Would either of you like to try it on here?
Mister, we barely know how to do it on. Yeah.
All right.
Because I put it right here, and then this one I'm confused because I put it up here, but then because Matthew said it goes right here, and then I double it because it's double, and then I don't know.
You want to try it? Okay. You need to graph the center of dilation. Yeah, the origin is what it is today. How far away is J from there?
1.
Okay, so that's a dilation of 1. I want you to do it how many times?
2.
So 1, 2.
Perfect.
No, but doesn't it go diagonal?
Because one of them would be that. We want to do that how many times?
2.
So 1, 2 times. How far away is L?
1.
1.
Yeah, and think of it this
So it'll be
way.
over
How much down and how much over?
1.
1.
So you're going to do that once.
And then twice.
That's a dilation of 2. Can you try that one?
So it's 1, 2.
No, but go from the center of
Oh,
dilation.
2 over 1. 2.
How much up?
1, 1. You go 1, 2, 1.
That's a dilation of 1. You want
1, 2, 1.
perfect. Connect them. That's a dilation of 2.
That's how you do it.
You want to try that one?
Alright.
All right. Yeah.
Stop. 1. Help. Like, what you doing? Just there and then. Okay, the origin and then. Okay, so that'll be here, right? So this one. Ah! Sorry. Like it wasn't hard. So. Alright, so K was right here. So from the origin it goes 1, 1. So 1, 1.
No, it goes 1, 1. It goes here.
Yeah, but it's dilation of 3 though.
Yeah, you gotta do it 3 times. So 1, 1, 1, 1, and then 1, 1. It's here.
Then
So
this
wait.
one.
I want to try myself. 1, 1, 1, 1, 1, 1.
And then 3 times, right?
Yeah. 1. Wait. 1, 2, 3. Yeah. I don't know how to do this one though. I go that way.
So 1, 3.
What the fuck?
Would it go right here? Would it be right here? Look. 1. So wait, 1 and then 2 and then 3.
I don't know.
No, it's gonna look a weird shape.
Because she said do it to the thing, and that's 1, 2.
That's looking good so far.
They confused with W.
That looks good.
Alright.
No. How far is W?
Oh my Jesus Lord.
1.
Yeah, then you're gonna repeat that.
Oh, so it goes down.
Because how did you go from the center to W?
You go down.
So that means you gotta go down too.
So you figure it out.
So U goes down here because, right?
Oh my
here,
God.
Because they're both connected. And then you make the shape.
Graph your center.
What the fuck is that?
How far away is L?
Yo, I swear to God. Okay, let me just see. Hold on.
Over and 2 down.
I'm sorry, I'm a perfectionist.
So don't go 2. Go.
Where?
And then don't go down 2. Go down.
What's a mouth?
I said where. That's not a curse word.
You know what I mean.
Oh, shit balls.
This is good.
Of 2. So 1 and then 1 and then 2, right? And then
This one goes like that. No.
so 1, 2 and then 1, 2 and then 1, 2. So wait, 1, 2.
I'm sorry. I'm just 1, 2.
wash your balls. I have a rash. I gotta stop taking the pills. Oh no, that's more stressful. I'm in my feelings.
I think W is wrong. Because if it's here, it doesn't make the same shape.
So W would be 1 and then 2. Wait, so 1 and then 2. So 1, 2. Let's see if that makes the same shape. Does it make the same shape?
Yeah, but
Elias, is that right?
Wait, go back. Yeah, it is. Because these sides aren't parallel. T is what I think is off. Yeah, it's diagonal one. Should be diagonal another. Well, that's 1, 2, 3. You want to go.
Oh, it says 1 and then 2 right there.
Perfect. Try that. That's gonna be good.
So basically, from the point, you just go down 2.
it looks the same to me.
Oh, that's cute.
Anyways.
So there, and then you go 1.
Jay don't go nowhere, boo. It's on in the thing.
But you, I can't point. I got 5 fat fingers.
You could point.
So this one goes 1. So here will be 3. So here you put the dot. Where? Right here. Because that will be 1 and then 2. No.
So this one does the same
1.
thing. 1.
So 1 and then 1, 2, 3.
No, it's from the origin, so it's 1, 2, 3. 1, 2, 3. And then it's 1, 2, 3.
Voila! Nigga said 0.5.
Ah! We ain't doing that one.
So this one will be 1, 2, 3, 4. Girl. Get in my feelings. I don't know what to do.
1, 2, I think.
1, and then 2, and then 3, and then 4.
No, that
3,
counts.
yeah. Leave me alone. I'm in my feelings. Do the same shit. Oh.
Unless it's 1, 2, 1, 2, 1, 2.
No. Because you have to go 4 down.
Yeah, but okay. So you see how this is like one box, most of the box. That's just one box.
Yeah, but you dilate it this way, like he said, so it would be 1, and then 2.
Yeah, but it's not directly in the middle. That's what I'm saying.
It goes 1 point before the end, like you put it. It's like right now, it's right there.
I put it already.
So that means this same point is gonna go for right here. Connect the buddy.
Nah, I'm your buddy. We're not doing that.
They're all numbers. So it's basically half.
We should be writing these on our paper. We over here doing them on here. Yeah, you do that on there. And then put both of our names on it, so I won't have to write it on mine.
1, 1. And then 1, and then 1. And then 1 and half.
Girl, you could just copy the picture.
How about you
You were
copy?
right. You were doing it right. I don't understand why you erased it.
I thought it was wrong because it said follow the picture.
Cause you're doing all this math, and I'm like, but you could just follow the picture.
You could do that one. I'll try to figure out this one.
Sorry.
Would it go on the negative side?
Anchovies.
That's what I heard. Anchovies. I heard anchovies. She said anchovies.
If you see that it says evenly divided, by 2 divided by roughly 1 by 1 is half 2 by 2. And then 5. Wait, hold on.
What?
Get that one.
I can't say yes, I'm my friend.
You just confused me. So basically, you do this part right here that just says the division part.
I thought you multiplied by 2. So I went here and then I went another one.
Look at this one. Oh shit. Let me ask Elias. Elias, how you do 0.5?
If it's over 2 and down 2, you go half. It's not over 2, it's half. It's over.
So whatever how many points it is, you divide it by half.
Divide by 2, yeah. Or multiply by a half.
Mister, we did it on the same paper because I don't feel like doing all that.
Okay, put both your names on it. Right here, right here.
I am small, number 7. Let me help number 7.
You go half. So instead of going up 2 and over 2, you're only going to go up how much? 1. And instead of going over 2, you're only going to go 1. Instead of going over 2, you're just going to go over.
Why are you giving us these weird shapes?
To make sure you understand it.
That's what I thought.